In the previous classes, you learned the basic concepts of coordinate geometry, like plotting different points in a two-dimensional plane using their coordinates or distances from the x and y axes. You also learned some important formulae, like the distance formula that gives the distance between two given points. For example, consider 2 points with coordinates -3, 4 and 3, 6. Using the distance formula, the distance between the two given points comes to 2 under root 10. You also learned the formula for finding the coordinates of a point dividing internally a line segment joining two given points in a given ratio. For example, consider a point C dividing the line joining points A and B in the ratio 2:3. By the ratio formula, the coordinates of C are -3 by 5 and 24 by 5. Suppose point C is the midpoint of the line joining the given points A and B. In this case, the coordinates of point C are given by x1 plus x2 by 2 and y1 plus y2 by 2. By the ratio formula, the coordinates of point C in this case are 0 and 5. You also learned the formula to calculate the area of a triangle whose vertices are given. For example, consider triangle ABC. Substituting the values of the coordinates of the vertices in the formula, the area of triangle ABC comes to 4 square units. Now, consider the case where points A, B and C lie on the same line or are collinear points. Applying the formula, we find that if points A, B and C are collinear, then the area of triangle ABC is 0. We can also say that if the area of a triangle ABC is 0, then A, B and C are collinear points. We come across many different kinds of lines in our daily life, like horizontal lines, vertical lines, and inclined lines. Generally, we call a line an inclined line when it makes an angle with the horizontal. The same idea of the slope of a line can be extended to coordinate geometry. A line intersecting the x-axis forms supplementary angles. The angle made by a straight line in the anti-clockwise direction with the x-axis is called inclination. Here, the anti-clockwise direction is also called the positive direction. The x-axis and the lines parallel to it are called horizontal lines. If line AB lies along the x-axis or is parallel to the x-axis, then its inclination is 0. The y-axis and the lines parallel to it are called vertical lines. If line AB is parallel to the y-axis or perpendicular to the x-axis, then its inclination is 90 degrees. The inclination of a line can have a value anywhere from 0 to 180 degrees. If theta is the inclination of a line, its slope or gradient is given by tan theta. The slope of a line is represented by m. The slope of a horizontal line is 0. The slope of vertical lines is not defined. Let us learn how to find the slope of a line passing through two given points. Let P, x1, y1 and Q, x2, y2 be 2 points on a non-vertical line L, whose inclination is theta. Since the line is not a vertical line, x1 is not equal to x2. Hence, theta may be an acute angle or an obtuse angle. First, let us consider the case when theta is an acute angle. Draw perpendiculars QR and PT from Q and P onto the x-axis. Draw perpendicular PM from P onto QR. Since QR is perpendicular to both the x-axis and PM, we have PM is parallel to the x-axis. Since PM is parallel to the x-axis, angle QPM is equal to angle QSX or theta, since they are corresponding angles. In right angle triangle PMQ, tan theta is equal to QM upon PM. Let this be equation 1. Now, QM is equal to QR minus MR or Y2 minus Y1. Let this be equation 2. Also, PM is equal to TR. This means PM is equal to OR minus OT or X2 minus X1. Let this be equation 3. Substituting the values of QM and PM from equations 2 and 3 in equation 1, we get the value of tan theta as Y2 minus Y1 upon X2 minus X1. Now consider the case when inclination theta is an obtuse angle. Draw perpendiculars QR and PT onto x-axis. Draw perpendicular PM from P to QR and extend MP to S. Since QR is perpendicular to both the x-axis and PM, we have PM is parallel to x-axis. Since PM is parallel to the x-axis, angle QPS is equal to angle QUX or theta, since they are corresponding angles. Since angle QPS and angle QPM are supplementary angles, and angle QPS is equal to theta, angle QPM is equal to 180 degrees minus theta. We can also say that theta is equal to 180 degrees minus angle QPM. Thus we get slope m of the line is equal to tan theta, which is equal to minus tan of angle QPM. Let this be equation 1. In right-angled triangle PMQ, tan of angle QPM is equal to QM upon PM or QM upon RT, since PM is equal to RT. Putting the values of QM and RT in terms of the coordinates of P and Q, we get equation 2. From equations 1 and 2, we get slope of the line is equal to y2 minus y1 upon x2 minus x1. Thus we see that whether the angle of inclination is acute or obtuse, the slope of a line passing through two given points is given by the same formula. Let us see if there is a relationship between the slopes of parallel lines. Here are two non-vertical parallel lines, L1 and L2, having inclination alpha and beta, respectively. If lines L1 and L2 are parallel, their inclination must be the same. Thus, we can say that angle alpha is equal to angle beta. Since angle alpha and beta are equal, tan alpha is equal to tan beta. By definition, tan alpha and tan beta represent slopes M1 and M2 of lines L1 and L2. Thus, we can say that if two non-vertical lines are parallel, their slopes are equal. The converse is also true, that is, if the slopes of two non-vertical lines are equal, the two lines are parallel. Now, let us find the relationship between the slopes of perpendicular lines. Here are two perpendicular lines, L1 and L2, having inclination alpha and beta respectively. Since line L1 is perpendicular to line L2, and line L1 makes an angle alpha with the x-axis, angle beta is equal to angle alpha plus 90 degrees. Let us take the tangent of both the sides of the equation. Tan alpha plus 90 degrees is equal to minus cot alpha. Also, cot alpha is equal to the reciprocal of tan alpha. Now, tan alpha and tan beta represent the slopes of lines L1 and L2 respectively. Putting these values in equation 1, we see that slopes of two perpendicular lines L1 and L2 are the negative reciprocals of each other. We can also say that the product of the slopes of two perpendicular lines is equal to minus 1. The converse is also true, that is, if the product of the slopes of two lines is minus 1, the two lines are perpendicular to each other.